So the formula of range is slightly different than what we've been looking at so far, but the same concepts are here, okay? Instead of playing with x's and y's, it's giving us a way to calculate the range of a projectile, and this is for projectiles launched at an angle, and this is for calculating, it's for calculating its x displacement. Okay, the range is the same thing. If I've got a projectile that's going from here, my range, all right, is from the starting point right through to where it lands. Okay, so the range here is another way of calculating your x final. Okay? And it's a way of calculating the full displacement of your actual projectile by not breaking down components. All right? Notice how this formula is VI squared. There's no x or y components. So if I say that my projectile is launched at 30 meters per second, okay, that is my VI. So in this case, you're going to know the angle at which it is launched. Or maybe that's the thing you have to find. Who knows? Okay, you could, in theory, if you were given the range, had the velocity, do you know G? Yeah. What is G? Oh, glad you brought that up, because here's the deal. Y is negative 9.8 meters per second squared. G is only 9.8 meters per second squared. There is no negative because G is a constant. It has no direction. It's just an amount. It's telling us what gravitational acceleration is. It's not telling us in which direction it's going. Okay, so that, I think one of the practice problem sheets you had dealt with a positive G. Okay, so you can use them interchangeably. You just have to remember your signs. Because this will totally mess everything up if you add a negative 9.8 to this. Okay? So the interesting thing about range, it's not a complicated formula. And it just gives you, I do find always that some students prefer to use this to find their x than using the actual, x formulas. For some reason, they seem to think this one's easier. It's going to give you the full range of, or it's going to give you the x final. So it's just another way of determining it. Okay? Okay, so we know that any time we launch a projectile, all right, the angle at which we launch it is going to determine basically how far it goes, correct? Now, in order to obtain maximum horizontal distance or maximum range for a projectile being launched, the maximum or the best angle that you can launch something at is 45 degrees. Okay? Because if you think about it, if you were to actually, if you were to break this down using trig, an angle of 45 degrees is going to that's got your maximum x and your maximum y together, right? Any other way, one of them is going to be shorter than the other. Yes? So, if you launch something at 45 degrees, that is the only way you can obtain the furthest distance possible. Case in point, the shoe toss. You want to launch your shoe, okay, so you got the person standing here, and you want to launch your shoe the furthest distance because that's what gets you the point. You want to make sure that you're actually launching it at a 45 degree angle. Because that 45 degree angle, okay, whether you break that down in the x and the y, so what I mean by that is that a 45 degree angle will have the longest x and y combined. They're pretty much equal in this case. Okay? Whereas if you go higher, you'll have a shorter x but a longer y. Doesn't work out that way. And if you go lower, you'll have a shorter y and a longer x. Doesn't work that way. So when you play something like Angry Birds and you want to launch a bird from the slingshot, if you want your bird, if it's just that normal red bird that doesn't do anything but just be launched the way you launch it, and you want it to go maximum distance, you're going to try as much as possible to hit that 45-degree mark. If you go at 50 degrees, okay, it will fall short. 50 is 5 above 45. If you were to launch it at 40, which is 5 below, it's going to give you the exact same spot. So here's where we start to see that anything up till about, 1 degree to about 89 degrees, let's say, will actually give you can find that angles will give you the same actual distance, with the exception of 45. 45 is kind of like the top of the pyramid, and then on both sides going down, we have those numbers as we get further and further away from 45. Your range decreases. Does that make sense?
Yeah, so like on a question, you basically give us the initial, and hey, what would be the maximum range, and all we have to do is replace our initial angle with 45.
Exactly.